Hello everyone, welcome to my channel again. I am Gayan Fernando and this channel is an educational channel. So if you wish to watch more videos, please consider subscribing. And if you prefer to get notifications, please hit the bell icon right next to subscribe button, so you will get notified whenever I upload a new video. So this lesson is the third part of the unit current electricity. So let's start the lesson. As I said before, this is the third part of the lesson, and in this video I'm going to talk about the variation of resistance and resistivity of a conductor with respect to temperature. We are going to analyze an equation for that, and next we are going to talk about superconductivity. Then we are going to talk about Ohms law, and finally what are ohmic conductors and non-ohmic conductors. So at the start, the relationship between temperature and resistance of a conductor. In second video, I explained that the resistance will be increased with temperature for conductors. If the temperature increment is low, pretty much low, then this increment will be linear. So we can get a linear equation for that. Let resistance at theta Celsius degrees be denoted by r theta. Then r theta equals r0 r naught 1 plus alpha theta. So r theta equals r naught 1 plus alpha theta. So r theta is the resistance at theta Celsius degrees measured in ohms. R naught is the resistance in 0 Celsius degrees measured in ohms. Alpha is the coefficient of resistance, which is and its units will be per Celsius or per Kelvin. Theta is the Celsius temperature increment or temperature difference measured in Celsius or Kelvin. We know for temperature differences, the value we get from Celsius and Kelvin will be the same. So this is the equation, and since R for a given conductor, L and A will be constant, so that R is directly proportional to rho. So we can write a mathematical equation from resistivity also. Rho theta equals rho naught 1 plus alpha theta. So this is the equation, and both of the remember, in thermal physics we have similar equations like this. For an instance, I can write L equals L naught 1 plus alpha theta. So keep that in mind in this equation, and the other one is A equals A naught 1 plus beta theta. So in these equations, L naught, A naught are the initial values, initial length and initial initial area. In these equations, R naught is not initial resistance, it is the resistance as at 0 Celsius degrees. Rho naught is not initial resistance, it is the resistivity at 0 Celsius degrees. Next, we are going to make a definition for alpha. If we write alpha from the above equation, from the equation for resistance, it becomes r theta minus r naught divided by r naught times theta. So if we put theta as 1, then the ratio between r theta minus r naught and r naught will be alpha. So how can we derive a definition? The ratio between resistance of a conductor at theta Celsius degrees to 0 Celsius degrees to the resistance at 0 Celsius degrees per unit increment of temperature will be equal to alpha. So this is the equation for alpha. And next we are going to talk about superconductors. So what is superconductivity? We know that when we increase temperature, the resistance of conductors will be increased, and vice versa. So some conductors, if we decrease temperature, the resistance at some temperature, the resistance becomes absolute zero. That is, when this is temperature, this is resistance or resistivity. When we decrease temperature, the resistance will decrease, and at a certain temperature, it becomes absolute zero. That temperature is known as critical temperature, denoted by Tc. So superconductivity is having absolute zero resistivity below the critical temperature. So superconductors are used in a temperature at a temperature below the critical temperature. So the important points to remember is in superconductors the resistance is zero, and also the magnetic field lines do not pass through superconductors. And uses of superconductors are we use them in medical science. We use them in MRI scanners, and also in supercomputers, and also in powerful turbines, and also in some cases we use them to electric transmission also. That's all about superconductivity. Then we are moving to Ohm's law. Ohm's law says that when temperature and other physical factors remain constant, then the current passing through a conductor is directly proportional to its potential difference, electric potential difference. So if this is a conductor, then if temperature and other factors remain constant, the current passes through, that is I, is directly proportional to potential difference, electric potential difference, V. So I directly proportional to V. This is the Ohmic law. So we take the constant, proportional constant, as R. Then we can write V equals IR. So V equals IR is the equation we derived from Ohm's law. V is potential difference, which is measured in volt. I is electric current measured in amperes. R is the electrical resistance measured in ohms. VIR, all these physical quantities are scalar quantities. Then we are moving into ohmic conductors. What are ohmic conductors? Ohmic conductors are the conductors which behaves accordingly to the Ohm's law. Simple as that. So the ohmic conductors, they behave as what the Ohm said. So ohmic conductors, for ohmic conductors, V proportional to I, and their resistance is a constant. So in this equation, I equals 1 over R times V. So this is the equation. So if we draw I, if we take I as y-axis, 1 over R as it is a constant, since R is a constant, V is the x-axis, we have a y equals mx diagram. So if we draw the diagram, it will be look like this. It will pass through the origin having a gradient of 1 upon R. So this is V, this is I, and this is the Vi characteristic for an ohmic conductor. Next, we are moving into non-ohmic conductors. So as the name tells, they do not behave according to the Ohm's law. So we analyze two such devices. First one is the incandescent bulb. Incandescent bulb is for them the V versus I characteristic will be look like this. The reason behind this is when some current passes through an bulb, it increases the temperature of the bulb. The increment of temperature will be result in increment of resistance, and increment of R will be result in decrease of 1 upon R, and this will result in this is the gradient. The gradient will be reduced. So that is why here the gradient will be decreased. So this is the characteristic for an incandescent bulb. The other one is junction diode, which will be explained in detail at electronics unit. So it will look like this. This is VB, which is known as breakthrough voltage. This is VPIV, known as peak inverse voltage. This is the characteristic curve for a junction diode. So with these diagrams, this video comes to the end. So hope you enjoyed it, and if you really enjoyed it, please hit the like button and consider about subscribing. So catch you in the fourth video in this lesson, and until then, goodbye and have a nice day.